In this problem, we will be considering the volume of the solid of revolution that's made up by the graphs of y equals root x, y equals x, and it's revolved around the y-axis. And we're going to use the disk method still. So first we need to note that y equals x and y equals root x intersect at the point 1, 1. And the object that we get will look roughly something like this. But the inside has a curved shape to it. The outside is straight edge to it to some degree. So maybe some kind of bowl is what's being formed here. Now, notice that our circles will be parallel to the axis of rotation. They're oriented vertically. So we are, since the circles of our disk method are oriented vertically, we will be integrating from 0 to 1. But everything needs to be, but our stack of circles is vertical, or in terms of y. So we'll be integrating with respect to y, which means our expression for radius needs to be in terms of y. Now this also is a washer problem. We've got a couple things to consider. Our outside radius goes from the y-axis to y equals x. And the good part about this is y equals x. If we were to find the inverse of that, we're going to get x equals y. Right? So the first part of our integral, from 0 to 1, I'll bring the pi out now, will be of y squared, because that's our the outside edge of our object. We need to subtract out that rounded plug that's coming out of the middle. And so our rounded plug goes from the y-axis to y equals root x. And the temptation is to plug in root x, but we can't do that because everything needs to be in terms of y, which means we need to solve this for x. Right. So x is equal to y squared. Right, our inner radius of our object is going to be y squared. So in our integral, we will be subtracting y squared dy. So we have our outside minus our inside. And everything's in terms of y because our circles are oriented vertically. If we clean this up, our integral will be from 0 to 1 of y squared minus y to the 4th dy. When we integrate, we get 1/3 y cubed minus 1/5 y to the 5th from 0 to 1. Plugging in the two limits of integration. When we plug in 1, we will have 1/3 minus 1/5 minus, when we plug in the lower limit of integration 0, we'll have 0 minus 0. 1/3 minus 1/5 is equal to 2/15 pi. So the volume of our solid rotated about the y-axis is 2/15 pi units cubed. So in order to get something in terms of y, you'll need to get the inverse of the function, or solve the function for x.